the R addition formulas. Just to get us started, let's consider these two graphs. I've got a graph of 3 sine theta and a graph of 4 cos theta, and I'm going to add these two functions together. When I do that, I get this black curve, 3 sine theta plus 4 cos theta. And you can see that by going along the theta axis and taking any point on the theta axis. If I add the height of the blue curve to the height of the red curve, I'm going to end up with the sum of those two is going to be the height of the black curve. If we do that right the way along from 0 to 400 degrees, in this case we would see this black curve. Right. Now, if you look at the height of the black curve, you'll see, which is also, you can see immediately that this black curve is going to be a sine or a cosine function, because it's got exactly the same typical shape, and the height of the curve is 5. And also, you'll notice that it's not the same as, if I was to draw the graph of 5 sine theta, it would be the same shape as the black curve, but it would be displaced. The black curve has in fact been displaced from the 0 position. It's been displaced backwards 53.1 degrees. Okay, so the combining of those two functions has actually caused the resultant sine function to be shifted back by 53.1 degrees in this case. And so the actual value of this function, or the expression for this function, the black function, is given by 5 sine theta plus 53.1. We have to add on this 53.1 to shift the curve sideways, to shift the curve backwards by 53.1 degrees. Now you might be wondering why the height of the black curve is 5 and why it shifts back 53.1. And that is basically what the R formulas tell us. So here we've got 3 sine theta plus 4 cos theta equals 5 sine theta plus 53.1, and the 5 comes from the fact that the square root of the squares of the coefficients of the sine term and the cosine term is equal to 5. And the inverse tan of the ratio of the coefficient of the cosine term to the coefficient of the sine term is given by 53.1, provided we only consider the angle in the first quadrant, or the acute angle solution. Right. Now, I could have drawn some other graphs with different values. Instead of 3 and 4, I could have chosen other values. So, in general, if we call the coefficient of sine theta A and the coefficient of cos theta B, and their combined sum R, you'll see that we get a formula that we write down like this, and this is called the R addition formula. Right, so and you can see basically where it's coming from. Now the alpha term represents the 53.1 degrees in our example, and now if we'd done the same thing but subtracted these two functions of sine and cosine, we would have got a similar expression, except we would have got a minus sign here, and where of course R is always the square root of a squared plus b squared in both cases, regardless of whether there's a minus or a plus sign. We always treat the coefficients of the sine and cosine terms as positive, and the angle alpha is given by the inverse tan of the ratio of b to a. Okay, now why do we use this? What use is this formula, or these formulas? Well, the reason we use them is because often when we get we find it very useful to when we get a mixture of coefficients, or if we often when we get the weighted sums of sine and cosine terms, it's convenient to replace that weighted sum by either a sine or a cosine function. And you'll see the benefits of that in a minute in the examples when we look at further in the video. Now, if we'd considered cosines instead of sines for the first term, so if I had an expression which is of the form a cos theta plus b sine theta, then I'd get a very similar formula, except it would be a cosine function. And I'd also find the fact that when instead of having a plus sign, I'd have the plus sign between these two terms becomes a minus sign when we add them together. Okay, so that's why when we get a cos theta minus b sine theta, we end up with a plus sign on the other side. Now we can prove these formulas. I'm not in this video. I'm not going to go into the proof of these formulas. I'm just going to go into what these formulas are, and I'll leave the proof to another video. But you can see that in general, when we want to talk about this, in the general form of the R formulas for the case where the first coefficient is cosine and the second coefficient belongs to a sine function, we write that as a cos theta plus or minus b sine theta is R cos minus or plus alpha. Okay. Let's put these to use and you'll see how useful they are. So I've got to, in this question, you've got to write 9 sine theta plus 12 cos theta in the form of R sine theta plus alpha, where R is greater than 0 and alpha is between 0 and pi over 2. Okay, let's start. Well, we know that this is of the form A sine theta plus B cos theta, so we know that it's going to be an R sine theta thing when we combine these together. Because A is 9 and B is 12, R is going to be the square root of 9 squared, 81, plus B 12 squared, 144, and then when you take the square root, you end up with 15. Also, the inverse tan of B over A, which is 12 over 9, turns out to be 53.1 degrees again. Which, now because the question has expressed alpha in radians, I've changed that to 0.927 radians. Okay, so part A is now complete. What about the second part, part B? Using the results from part A, solve the equation 9 sine theta plus 12 cos theta equals 3. Right, so this is where we can rewrite 9 sine theta plus 12 cos theta in the form of 15 sine theta plus 0.927. Okay, I should have mentioned that at the end of the part A. Right, so we know that that's what R sine theta plus alpha is. It's the sum of these two terms. So when we come to the part B, all we do is we substitute for 9 sine theta plus 12 cos theta, we substitute our 15 sine theta plus 0.9273, and we're told that's equal to 3. We need to now solve this for values of theta in the range of 0 to 2 pi. Okay, so easily done. Divide both sides by 15, and we end up with sine theta plus 0.9272 is 0.2. And therefore, taking the inverse sine of both sides, we end up with and expressing the result in radians, we end up with theta plus 0.9272 is either equal to 0.2013 or pi minus 0.2013 or 2 pi plus 0.2013 and so on. Now I've stopped there because that would because looking at these solutions, I can see that if I produce any more solutions, they will cause us to go outside of the range of theta, which is between 0 and 2 pi. So having done that, I then just take having expressed theta in that form, I then just take the 0.9272 across the equal sign to end up with the actual values of theta, which solve this equation in radians, which are 2.01 and 5.56. Okay, part C. Now part C is another application of the R formulas, and you can see that this function at the moment is a function of sines and cosines, but because of the the result of part A, we can replace the 9 sine theta and 12 cos theta by 15 sine theta plus 0.927, and of course that's been subtracted from 10. That 9 sine theta and plus 12 cos theta has been subtracted from 10, so that our function f of x is in fact 10 minus 15 sine theta plus 0.927. Now you can see it's best to look at this function in 2 bits. The bit on the right is a sine function whose maximum value is 15, and on the left hand side we've got just the number 10. So in order to find the maximum and minimum values of this function, I need to consider the only thing that's going to affect the maximum and minimum value of this function is the 15 sine theta plus 0.927. So if we now realise that 15 sine 9 theta plus 9.927 has a maximum value of plus 15 and a minimum value of minus 15. So essentially we're going to take, so the maximum value of f of x is going to occur when we subtract minus 15, when the 15 sine theta plus 0.927, when the sine term is at its minimum value and it becomes minus 15, then the function f of x is actually going to reach its maximum value, because it's 10 minus 15, or 10 plus 15, which equals 25. Okay, so the maximum value of this function is 25, and the minimum value of this function is going to occur when the sine term equals plus 15, and in that case the result, the minimum value, turns out to be minus 5. Okay. Here's another question. Write 5 cos theta plus 12 sine theta in the form of r cos theta minus alpha, where r is greater than 0 and alpha is between 0 and 90. Right, so looking at our R addition formulas, we can see that a is 5, b is 12, r is therefore going to be the square root of 25 plus 144, which is 13, and the inverse tan is going to be the inverse tan of 12 over 5, which is 67.38 degrees, or 0.927 radians. Right, so part A done. And therefore we can write the 5 cos theta plus 12 sine theta, this mixture, basically it's a rewriting of the weighted sums of the cosine and the sine terms in the form of a cosine function now, and the cosine function turns out to be 13 cos theta minus 67.38 degrees. Okay, now for part B, we can now solve this equation, because what we're going to do is replace the 5 cos theta plus 12 sine theta by our newly formed R function, because we've now combined these into a single function, 13 cos theta minus 67.38, and it's that cosine function which is equal to 2. So it's a simple solution now of just solving this equation, and when we do, we get cos theta minus 67.38 is 2 over 13, and therefore theta minus 67.38 is the inverse cos of 2 over 13, which has values of 81.15, or it could be 360 minus 81.15. Okay, so when we substitute those in, now there could be other values as well, but we're told that the range of theta has to be between 0 and 360, so we don't need any more solutions. And when you take the 67.38 across the equal sign, you end up with the solutions of 148.53 degrees and 346.23 degrees. Okay, so straightforward. The third part, which is another use of the R-value formulas, it allows us to find maximum and minimum values of mixed coefficient combinations of sines and cosines. You can see that this time this expression that we want to find the maximum or minimum value of can be rewritten by substituting for the 5 cos theta plus 12 sine theta. We can replace that by our 13 cos theta minus 67.38 degrees. And of course that expression is 5 cos theta plus 12 sine theta cubed, so we need to cube this. Now, because the maximum value of the inner part of this function, or this expression I should say, is 13 cos theta minus 67.38, we know that its maximum value is going to be plus 13 and its minimum value is going to be minus 13. So therefore, to find the minimum value, it's going to be when we choose the minus 13, or when that function becomes a minus 13. So the minimum value of the expression 13 cos theta minus 67.38 cubed is when we replace that by minus 13, and minus 13 cubed turns out to be minus minus 2197. I'm sorry, I've got a double minus there. I don't know how that cropped in, but it comes out to be minus 2197. Okay, so I hope this has given you a brief introduction to the R-value formulas, and I haven't given you the proof of them, but they're very easy to derive from the double angle, from the double angle formulas. So we can do that in another video. Okay, thank you.